Okay, so today I will be solving a transportation problem from the LPP chapter, Linear Programming chapter. This is present in the ISC 12th grade curriculum. I'm solving the 16th solved example from the OP Malhotra textbook. Once you understand this concept, it's going to be very easy for you to follow similar questions. This comes in the section C of the ISC board paper. It's a very important type of problem. So, start reading the problem with me and we'll make the required notes. A brick manufacturer has two depots, A and B, with stocks of 30,000 and 20,000 bricks respectively. He receives orders from three buildings PQR for 15,000, 20,000 and 15,000 bricks respectively. The cost of transporting 1,000 bricks to the builders is given below. So since you're taking everything with respect to 1,000 bricks, I'm going to divide each, like say A has 30,000, I'm going to divide it and make it 30. I'm going to divide it and make it 30. Okay, just give me a minute. Yeah. Since B has 20,000, I'm going to make it 20. So the calculations further get easier. Now we have three buildings, building P, building Q, and building R. Building P requires 15,000. So we're going to go with 15 bricks. Q requires 20 and R requires 15. Now we're going to make a chart to show how the transportation has actually worked out for us. Say this is your... Okay. A has sent X units to P. Let us say it sent Y units to Q. And naturally, it would be sending 30 minus X plus Y units to R. Now, B requires 15 units in total. It has already received X units. So B will supply 15 minus X, which will satisfy the requirements of P. Q will give us 20 minus Y, which will give us the requirements of building Q. And R requires 15 units. That's going to be this total. So we're going to do 15, that is the requirement, minus what has already been supplied. So on opening this equation, we'll get X plus Y minus 15. After this is clear, we can see that we have a price given. So from A to P, the price is rupees 40. From A to Q, the price is rupees 20. From A to R, our price is rupees 30. We're just going to make notes of it down here. 1 minute. Yes. Now, from B to P, our price is rupees 20. From B to Q, the price is rupees 60. And from B to R, our price is rupees 40. Once this is clear, we will be making the total cost required by building P, by building Q, and building R. So P would be requiring 40x plus 20 into 15 minus x. I'm taking this combined cost and this combined cost, which will give us 40x minus 20x plus 300. That is 20x plus 300. Next, Q will be 20y plus 60 into 20 minus y, which will give us 1200 minus 40y. And R will be 30 into 30 minus x minus y plus 40 into x plus y minus 15. On solving this, we will be getting 10x plus 10y plus 300. Now, to get the total transportation cost, we need to add up these three equations. Am I correct? So I'm going to write this as 20x plus 300 plus 1200 minus 40y plus 10x plus 10y plus 300. And all this is in thousands. We can't forget that. We have divided everything. That we'll mention now. So our total cost is going to be rupees 30x minus 30y plus 1800,000. Okay. Now, what do we have to minimize? So as we know in the other sums of LPP, this equation is our Z. This is what we need to minimize or maximize. In this case, we've been asked to find the minimum transportation cost. So you have to minimize this equation with the constraints. Now, we know x is greater than equal to 0, y is greater than equal to 0, and each of the other equations all become your, like you say, x plus y is less than equal to 30, x plus y is greater than equal to 15, x is less than equal to 15, y is less than equal to 20, and these two. How do we get these equations? Is from here. X plus y equated to 0. So x plus y has to be less than equal to 30 in order for this to be 0, because the cost can't go into negative. Then you do this. X plus y has to be greater than equal to 15. Because only if it's greater than equal to 15, you won't go into negative. X has to be over here. X has to be less than equal to 15. Y has to be less than equal to 20. And x and y are both positive. So this is your LPP problem. This is your final answer, which will be written with minimize. You will write minimize this subject to the constraints. In LPP questions, they usually won't ask you to solve the entire problem. But if they do, we'll equate each equation. You'll make your XY table, correct? And you'll find your points, whatever your points are. You'll plot your points onto the graph. You'll find your region of feasibility. You'll you can say substitute your points of region of feasibility into your Z equation, and the minimum value will be your minimum required money. But here they've just asked you to give us the LPP problem. So this out here is your final answer. I hope this was clear, and I hope this video was helpful to everyone.